if you have a beam looks like this, and you have concentrated load here, 5 kip or 5 kilonewton or whatever, the bending moment diagram will be something looks like this. M naught. That makes sense? If we are looking for theta at A, if you are looking for theta at A, I will remove everything. At point A, I will put here 1 kib foot unit moment. Your bending moment diagram will be this triangle. So this one is negative, this one is negative, this one called M1. So theta at point A will be integration of M naught with M1 divide EI DL. Any question so far? If you would like to make integration between M naught and M1, please be careful. The first part, this triangle with 0. So triangle, integration of this triangle with 0 will be 0. That makes sense? So if you have diagram for M naught and nothing for M1, okay, the integration will be 0. That makes sense? The second one, be careful about integration of this triangle with this triangle. What is the problem? We covered this before many times. No, be careful. For this table of integration, we have two cases right now. This triangle with this triangle, the integration equal 1/3 m time L. We have another case. This triangle with this triangle. The integration equal 1/6 m time L. So why this one is 1/3? Why this one is 1/6? And what is the difference? Be careful. If you are integrating this triangle with this triangle, this side and this side in the same, looks the same exactly. So your integration will be 1/3 m time L. M naught time M1, M naught, M1, and this is the length L. And this is the case for this triangle and this triangle, this moment and this moment on the same side. But if you have this triangle as M naught and this triangle as M1, so right now we have different scenario, because this moment and this moment in opposite sides. So your integration will be 1/6 m time L. That makes sense? So please be careful about integration of triangle with another triangle. Make sure which case you are in. This one and this one, or this one and this one. So I believe if you would like to integrate this triangle with this one, your case will be 1/6 m time L, not 1/3. Any question? Any question, guys? Do you have any question regarding this point?
I have a question, but it's from the homework.
Related to truss or beam?
Beam.
So what? Just a second. Homework number 10, I think. No, not number.
It was somewhere number 10.
Okay, question number 2, I believe.
Number 2, yeah. So how would we treat that 400 and
Say it again.
how would we treat that 400 N on the M naught? Do we do
Okay.
it together or
Okay.
separate?
No. What is the meaning of superposition? Superposition means I will assume this cantilever with distributed load alone.
Yeah.
Plus this cantilever with the concentrated load alone. This is the meaning of superposition. Assume every load is existing alone. So this one will give you a triangle PL. This one will give you a triangle WL squared divide 2 and parabola. So the final, we will have two triangle here, another triangle, and one parabola. This called M naught. So we have two triangle and one parabola. Does that make sense?
Okay, and then when we're doing our addition, we just add them all together, right?
No, don't add them together. We have triangle, we have parabola. Three shapes. If you would like to integrate these three shapes with, for example, with another triangle like this, M1, okay, go ahead and make integration between parabola and triangle plus triangle and triangle plus triangle and triangle.
Okay. Yeah, that's what I did. All right.
Yep.
Okay, thank you.
So superposition, guys, means you can assume every single load is existing alone. This is the meaning of superposition. Any question? Okay. I will continue solving examples for visual work of trusses. For this truss, we need to figure out what is the horizontal deflection of joint D. This joint will move laterally, will move horizontally. We need to figure out how much horizontal deflection. Okay, we don't care about horizontal or vertical or whatever in the first step. Do you remember what was the first step? The first step, we need to solve the truss D2 given load. So we have 6 kilonewton, we have 6 kilonewton. We need to solve this truss. Okay, I will start with reactions. I have here two reactions. I have here one reaction. I think if you apply summation f of x equals 0, this reaction will be 6 kilonewton. If you apply summation f of y equals 0 and summation moment at any point equals 0, I think this reaction will be 6 kilonewton. And I think this one will be 0. 0 reaction. If you take moment here, this one will be cancelled. So yeah, I'm sure. Okay, so I found reactions. Why you found your reactions? Because I need to solve this truss. Okay, what about joint D? Here is joint D. We have vertical force 6 kilonewton. We have horizontal member and the vertical member. I will assume this one tension and this one tension. F AD, F DC. If you apply summation f of x equals 0, I believe f dc will be 0. This member 0. Okay. If you apply summation f of y equals 0, I believe negative 6, negative FAD equals 0. FAD in one side will be negative 6. What is the meaning of negative? I assumed the wrong direction. I assumed the tension. No, I'm sorry, it's a compression. So FAD will be compression on this side and the compression on this side. How much? 6. Compression. Compression. What else? What do you think about joint B? Let's try joint B. Okay, for joint B, what do you have at joint B? We have vertical reaction 6, we have horizontal member, we have vertical member. Nothing else at joint B. I believe without calculations, this one will be 0. We don't have anything in X. I believe this one will be down. How much? 6. So this one will be compression 6 and compression here 6. Compression. Remember, compression. Because compression means negative. Compression means negative. And this one is 0. We still need one more. What about this member? So if you would like to solve this member, I will consider joint C. Here is joint C. This member is 0. We have 6 kilonewton. We have vertical force 6. We have inclined member. I will assume a tension F AC. I believe this angle is 45 degrees. This angle 45 degrees because we have 3 and 3. If you apply summation f of y or summation f of x or summation f of x equals 0 or summation f of y equals 0, I believe I can figure out what is the value of FEC. It will be 8.5. So this one will be tension. This one will be tension 8.5. All of these forces in these members will be considered capital N. So all of these calculation only the first step. Solve the truss due to the given load. The first step is chapter 3. So I started first with reactions. Then I considered each joint. Joint D, joint B, joint C, to figure out the internal forces in each member, the internal force in each member. If your force is compression, it will be considered negative. If your force is compression, will be considered compression. If your force is tension, will be considered positive. Any question so far? This is the first step only. Second step. Second step. Anybody remember what was the second step? Remove all loads. Okay, here is the truss. I will remove everything. If you remove everything, reactions will be removed also. A, B, C, and D. After you removed all loads, what should I do? I will put unit load horizontally at D. I'm sorry. Why I put unit load at D? Because the problem asked for this. We are looking for displacement at point D. Why you put this unit load horizontally? Because I'm looking for horizontal deflection. Horizontal deflection. So at point D, I will put unit load, how much? 1. 1, what is the unit? Kilonewton. Horizontally at point D. Go ahead and solve this truss one more time. So we have a new truss with new load. So we have new reaction. I think we have reaction here. We have vertical reaction here. We have horizontal reaction here. If you apply summation f of x equals 0, this one will be 1. If you apply summation f of y equals 0 and summation moment at any point equals 0, I believe this one will be 1 and this one will be 1 kilonewton, kilonewton, kilonewton. So we have reactions. After you are done with the reactions, go ahead and consider joint D. What do you have at joint D? We have horizontal load 1, we have horizontal member and vertical member, nothing else. I think if you apply summation f of x equals 0, summation f of y equals 0, I think this force will be 1, this force will be 0. So this one will be 0, this one will be compression 1. Compression. Compression means negative. If you take care of joint D, joint B. Here is joint B. We have vertical force 1, we have horizontal member, we have vertical member, nothing else. If you apply summation f of x equals 0, this one will be 0. If you apply summation f of y equals 0, this one will be compression here and compression there. 1, compression. Compression means negative. Then, if you consider joint C, for example, joint C, we have horizontal force here 1, we have vertical force here 1, and we have inclined force here F AC. That makes sense for this joint. If you apply this angle 45 degree, if you apply summation f of x equals 0 or summation f of y equals 0, I think this force will be 1.4. Tension. So this force will be tension. This force will be tension, 1.4 tension. Tension means positive. So I am done with the internal force in each member. This called small n. So right now, I solved my truss 2 times. The first time due to the given load. The second time when you removed all external loads and you put only unit load. So we have only unit load. I will solve the truss one more time. Figure out the reactions and apply joint equilibrium at each joint. The last step, horizontal deflection at D that we are looking for equal summation capital N small n time L divide EA, and we will set up a table. The first one in the table, members. Please go ahead and put your members. We have 5 members. So we have member AB, we have member BC, we have member CD, we have member DA, we have member AC. 5 members. What is the length of each member? 3 meter, 3 meter, 3 meter, 3 meter, and 4.2 meter. This one is 3 meter, 3 meter, 3 meter, 3 meter, but this one will be 4.2 meter. What is the capital N, the internal force in each member? Okay, this one is 0, -6, 0, -6, and positive 8.5. Okay, 0, -6, 0, -6, positive 8.5. Please be careful. Positive or negative in this table means positive means tension, negative means compression. So this value is 0, this value is negative compression, this value is 0, this value is negative compression, this one is positive tension. The third or the next column, small n. What is the small internal force? What is the small n in each member? 0, -1, -1, 0, positive 1.4. So we have 0, -1, -1, 0, positive 1.4. Can you set up the last column, which is capital N times small n times L? Go ahead. 3 times 0 times 0 equals 0. 3 times 6 times -1, -18. 3 times 0 times -1, 0. 3 times -6 times 0, 0. 4.2 times 8.5 times 1.4 equal 50. Go ahead and find the summation of this column. 0 minus 18, 0, 0, 50. Your final answer will be 32. This is the summation. So your deflection, horizontal deflection at point D equal 32 divide EA. The numerator, which is summation capital N times small n times L, this numerator equal 32. So 32 divide EA. Your value is positive. Anybody can tell me what is the meaning of this deflection equal positive value? Any answer? What is the meaning of positive 32 divide EA? What does it mean? Which direction? Okay, I assumed right direction. What is the right direction? I need conclusion. What is your conclusion? Wow. Wow. Wrong answer. I bought, because I'm looking for horizontal deflection at D. I put unit load at point D going to right. I put the unit load at point D going to right. So my assumption is correct. This point will move to right. We are looking for horizontal deflection method. Okay? Okay. So guys, this type of problem in your exam will be very easy, but very long, because we have three main steps. Solving the truss due to given load, then solving the truss one more time due to unit load, then set up this table. We'll need some time to set up this table and put your numbers. One of you will say, hey, what will happen if I don't have time in the exam? Okay, you solved the truss and you found capital N correctly. You removed everything and put unit load, and you solved the truss one more time and you found small n. But you don't have time to set up this table. Believe me, I will give you a good credit, because I understand and I am sure you can solve the truss and you set up everything, but you don't have time. Another scenario, one of you did not solve the truss and he did not find capital N, and he did not find small n, and he set up the table and keep it empty without numbers, I will give you 0, because I am sure you are not familiar with truss. You cannot solve the truss. Does that make sense? So I'm not asking for steps. I know everybody can know what are the steps, but did you get any numbers, anything in the problem to prove that your issue is the time? So be careful about this point. Okay, one more example. But before starting the last example, any question so far? Any question? For BC. In the table? Yeah. Thank you. Why? This one is negative. So 3 times negative 6 times negative 1 is positive. So who did this one is negative? I'm sorry. It will be 86. Thank you. So 3 times negative 6 times negative 1 is positive 18, not negative. Thank you, Ben. Any other question? Okay. We have another truss, which is bigger a little bit, and we need to figure out what is the vertical. So please, guys, make sure you read the problem carefully. We are looking for horizontal or vertical. Big difference. Big difference. We are looking for vertical deflection at point A due to the given load. Okay, that's good. But the first step, we don't care about what is the required. The first step, we need to solve this truss due to the given load. I think we need to start with reactions. We have here one reaction. We have here two reactions. If you apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0, I think this reaction will be 500. I think this reaction will be 1000 and this reaction will be 1000. I think this member and this member will be 0 force member because I have joint without external load and we have only 2 members, so both of them will be 0. I think this member will be 0. I think this member also will be 0. So if we consider joint F, yeah, I know this truss is more complicated. For joint F, what do you have at F? We have vertical force 500. We have horizontal member and inclined member. What about the third member? It's 0, so I removed it. So we have FE, we have FB. We can assume this one tension and this one tension. I think this angle will be 45 degrees. Go ahead and apply summation f of x equals 0, summation f of y equals 0. I think this one will be 700 FB will be negative 707.1 and FE will be positive 500. From your calculations, positive means correct direction. Negative means wrong direction. So if FB, I assumed a tension, I'm sorry, it's compression. So this force will be compression. This force will be compression. How much? 707.1 compression. If FE is positive, means you assume the correct direction, which is tension. So this one will be tension. This one will be tension. How much? 500. I think at joint E, this one will be tension also, and this one will be tension 500. Because this one is 0, is nothing. I think at joint C, I know some of you will say why the vertical member here is 0. I covered this before, if you remember. For joint C, what do you have at joint C? We have horizontal reaction 1000. We have horizontal member and the vertical member. Nothing else. Nothing else. The vertical member equals 0. Do you know why? Because if you apply summation f of y equals 0, nothing in y except this member. So this member will be 0. If you apply summation f of x equals 0, this one will be 1000 compression. Compression. I am done with all members except this member. Okay. I can do joint equilibrium at D. Joint D. What do you have at joint D? We have tension here, 500 in this member. We have horizontal reaction here, 1000. We have vertical reaction here, 500. And this vertical member is 0. And we have inclined member here. I'm going to assume it tension F dB. This angle is 45 degrees. If you apply summation f of y equals 0 or summation f of x equals 0, you can figure it out. This member will be 707.1 tension. After you are done, I solved this truss and I found the internal force in each member, which you consider capital M. This is the first step. Take your time. We need to solve this truss to find the internal force in each member due to the given load. Chapter 3. Next step. Remove all loads and put vertical unit load at A. I understand we need to put unit load at A. Why? Because we are looking for deflection at A. Why the unit load is vertical? Because we are looking for vertical deflection. Here is the truss. Oh, I'm sorry. That's right. I removed everything. I removed everything from the truss. At point A, I will put vertical unit load. 1. What is the unit? Pound. So 1 pound. We have a new truss with new reactions, with new calculations. Go ahead and find your reactions. I think if you apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0, I think this reaction will be 333. So 1 times 9 divide 3. This one will be 3. This one will be 3. This one will be 1. Go ahead and find the internal force in each member. So I will do it quickly. You should solve it one by one. I think this one will still 0. This one will be 0. Compression here 3. I think this one will be tension 1.4, compression 1, and this one will be compression I think 1.4. I think this one will be tension 2, tension 2. I think this one will be 2.8, compression 2.8. Are you sure? Wait a moment. Looks like there is something wrong. 1 divide cosine 45, 1.4. Okay. I think this one will be 1.4, 112, 2. Yeah, wait. This value is wrong. And this direction is wrong also. This member will be tension, how much? 1.4. That makes sense. Okay, so this one can called small n. I know you will take long time to solve this truss one more time. The final solution is vertical deflection at point A equals summation capital N small n time L over EA, and I need to set up a table. The first column in the table, each member. Go ahead and put your members. AB, BC, CD, DE, EF, FA, BF, BE, and BD. We have many members. 1, 2, 3, 4, 5, 6, 7, 8, 9 members. So go ahead and put your members. What is the length of each member? What is the capital N in each member? What is the small n in each member? And the last column, we need to multiply L times N times L. And find the summation. This summation will be the numerator for the final deflection. If your value is positive, this point moved down, because I assumed the unit load moving down. If your value is negative, I'm sorry, your point moved